everybody, this is Rudra Pradhan here, instructor in charge for engineering econometrics, and first of all welcome to this particular subject, that is engineering econometrics, and today is our first lecture, that to introduction to engineering econometrics. Before we start the first lectures, let me first highlight the course contents that will be from unit 1 to unit 12. So, the course content will be like this. In the unit 1 we will discuss introduction to engineering econometrics, and here we will discuss various aspects of econometrics, the kind of requirement, the kind of scope, and the kind of engineering area where we can target and address the problem. And then we will move to unit 2, where we need to know the use of the data and the spreadsheets, because this is a quantitative subject, and here we like to use mathematics, statistics and statistical softwares, and for that the use of data and the kind of spreadsheet is very essential, and that is how in the unit 2 we will discuss all details. And then in unit 3 we will have descriptive econometrics. Here all kinds of requirements we will address, the need of the particular techniques and the kind of requirements like inference, distributions, probability and something like that, because these are all essentials for some of the complex modeling and as per the particular engineering problems requirement. And then we will move to unit 4, where we will discuss some kind of real econometrics work, that is on regression modeling. And in the regression modeling, that is on linear regression modeling, and in the linear regression modeling we will discuss various aspects of structure, starting with simple one and the complex one, and then followed by unit 5 and unit 6, where we will discuss various aspects of model diagnostics, and then we will have some kind of testing and something like that, and then we will address the particular requirement. We will move to unit 7, where we will discuss nonlinear regression modeling. In the like linear regression modeling, we will have a plenty of different models and the kind of requirements, the kind of testing, then the kind of diagnostic checks, and then we will move to week 8 and week 9, where we will discuss time series aspects of regression modeling, because some of the engineering problems can be connected with time series data, and for that different types of time series models are there, where we can use this time series model, and then we can address the engineering problem as per the particular engineering requirement. And then we will move to unit 10, where we will discuss panel data modeling. And in the panel data modeling, we have a different types of models depending upon the particular engineering problems requirement, and where we will discuss types of model like fixed effect model, random effect models, and generalized methods of moments and so on. And then we will move to unit 11, where we will have a count data and discrete modeling, and then in the last unit we will discuss couple of different special kind of modeling, that is called as duration modeling, and the details items we will highlight in the first lecture itself. And let us start with the kind of introduction to this particular engineering econometrics. Ultimately the structure is like this. So what we can do, so we start with the introduction to engineering econometrics, and where we will address some of the issues behind this econometrics and the kind of engineering problem. And in the introduction to engineering econometrics, we start with the following components: what is all about econometrics, then second the coverage of engineering econometrics, then classification of econometrics tools, and then finally a framework of econometrics depending upon the particular classification, and a scope of econometrics, and finally data understanding for engineering econometrics. And in the last part we will discuss engineering econometric models. So, that means these are the following components we like to address in our first lecture. So, let us start with what is all about econometrics. So, econometrics technically is a quantitative subjects, and where we have the structure of quantitative analysis of actual kind of scenario based on a particular development of theory and observations and relating to appropriate methods of inference. So, technically it is a part of the mathematical science, and as the things are like this is a like applied kind of subjects, where we have the integration of both mathematics and statistics to some of the engineering problems. So, there is no specific engineering area, but here the idea is you will discuss different kind of techniques, and then we will connect with a particular engineering problem. So, altogether econometrics is the systematic process of using a theory, a model, and using theory, model, and then data, and to get innovative insights for the decision making process. So, that means altogether three things here. So, theory is one part, model is the second part, and data is the third part. Then we like to actually integrate, and in fact, in the model itself we have the structure of mathematical modeling, and we have the structure of statistical modeling. There is a little bit difference between the mathematical modeling and statistical modeling, where the idea is the theoretical aspects or the kind of problem, the real life engineering problems can be transferred into a form of a mathematical model, and using that mathematical models we will convert into a statistical form, and then we will go for some kind of empirical testings by using the data and the kind of techniques, and hoping that there will be something new insights from the existing theory, or the kind of the revisit of this particular theory with the help of different techniques, different tools, and the different data structure. And the particular insights can give you some kind of hints to solve the engineering problems. And so, technically it is the integration of theory, then model, and data. So, this is a kind of empirical process altogether, and then we will get some kind of new insights, and that new insights will help you to go for some kind of decision making process. So, econometrics altogether extensive use of mathematics, then statistics, and as usual I have discussed that there is a requirement of data and models, and then a fixed base kind of theory to obtain the decisions and actions as per the particular engineering requirement. So, we have a couple of engineering problems where we need actually some kind of systematic decisions or accurate decision, and having theoretical information, having some kind of data. So, engineer cannot easily come with a kind of excellent decision or proper decision to address the problem. So, what we can do here we will take the help of econometrics, which can simplify the particular process much better way, and come with a kind of new insights and some kind of fact based observations through which you can address the engineering problem in a much better way. So, that is how the kind of structure, and then ultimately, so we will move to this particular structure called as uh, uh, the understanding of econometrics, and that to the particular engineering area. So, altogether econometrics is a if I summarize like whatever we have discussed in the last slides, in the last slides our focus is on 4 aspects, the use of mathematics, the use of statistics, and the data, and the kind of model. So, here we just summarize the kind of structure. So, it is the branch of mathematical science, and that seeks to measure and correlate the relationship among decision variables, and it combines theory expressed in mathematical form with appropriate statistical methods. That means we will start with a particular engineering problem, and that engineering problems can be addressed or can be analyzed with a set of decision variables, and the whole process is to empirically verify or test the theory with these decision variables. And by the way, for the decision variable we must have data, and we must have some kind of baskets of technique through which you can pick up a technique, and then we can use the data, and then we will revisit or restructure the particular theory to get some kind of new insights to address the engineering problem. And ultimately the structure is like this. So, we have here theory, and then we have the decision variables. Of course, the decision variables are coming from the theory, and then we have some kind of data, and then we will go for empirical process. The empirical process technically needs data and the technique to examine the existing theory, and that too with the help of decision variables. So, in the one part it is a theory, and the theory will give you the structure of decision variables. So, we then need data and techniques, and then in the technique baskets what we call as econometrics. So, this is what the kind of techniques basket. So, theory will give you the kind of structure of decision variables, and then against all the decision variable we have here data, that is the information, and then econometrics job is how these information corresponding to these decision variables, and that too corresponding to the particular theory, will be examined in a systematic way to get some kind of insights which may be very innovative, which may be something new, and to address the same engineering problems in a different way, and that will give you some kind of excellent and perfect decision making outcome. And altogether it is the equation of or the relationship between theory and data, and that too with the help of the econometrics technique or econometrics tools. So, this is how the kind of structure. After knowing the kind of concept econometrics, then we will move to the concept of engineering econometrics, which is not something actually different. It is a econometrics. So, the field which or where we can apply the particular quantitative technique is called as engineering area. So, we have a plenty of engineering area, starting with aerospace engineering, agricultural engineering, mining engineering, mechanical engineering. So, we like to address some kinds of engineering problems, not specifically for a particular engineering, and then we will address the on the problem in a more effective way. The idea is that this is a kind of technique, this particular subject, that is the econometrics. It can be used any kind of engineering problems. So, the whole idea or the objective of this course is like this. So, you should know the econometrics concept or the tools of econometrics, and then you think where we can actually apply this particular technique to address the engineering problem more effective way. So, once you know these techniques, so then you can apply as per your expertise and the as per the particular your requirement. So, that is how we should know first the kind of econometric structures, and then you can go for the kind of discussion. So, engineering econometrics technically is the use of engineering theory, mathematics, statistics, data, then you can say that softwares or some kind of computer based analytics to help specifically engineers to gain improved insight about their problems and make better or some kind of fact-based observations or decisions. So, this is what actually the whole concept of engineering econometrics or the literary meaning of engineering econometrics. So, now the thing is that what are the coverage which we can which we have here in the case of engineering econometrics. So, the structure is start we can start with aerospace engineering, and then agricultural engineering, biotechnology, chemical engineering, environmental engineering, geology and geophysics. Then we will connect with also industrial engineering, mechanical engineering, metallurgy and material sciences, and then mining engineering. So, that means in fact, these are not the only engineering area. So, we have lots of other engineering area, but in the course particularly whatever units we have already highlighted. So, more or less we will discuss some of the problems corresponding to these engineering only. So, that is how our focus is not a particular engineering kind of aspects like may not specifically towards aerospace or something like agriculture or something like biotechnology. So, the whole idea is we have a plenty of econometrics tools. So, whenever we will discuss a particular tool, we will pick up a particular problems and to address the technique, and then we will check how this technique can help to solve these engineering problems and to look for some kind of new insights or better insights for the requirement of decision making process. So, we can start with aerospace engineering, and in the next problem or in the next technique the particular application may be towards biotechnology or chemical engineering. So, that means once you know the techniques, so you can use your engineering problems to apply this particular technique and to get some kind of new insights. So, in sum we like to target different aspects of engineering with different econometrics tools. So, the structure is like this. That means technically we like to see what are the components under econometrics modeling, that too for engineering problems. So, in the unit structure itself we have already highlighted, but now I will give you the complete structure item wise requirement from the linear regression modeling to some kind of complex modeling. And then in the first case we will start with linear regression modeling, where we will discuss some kind of simple structure that is called as a bivariate structure, and then we will connect with a trivariate structure and a multivariate structure, and then finally we have some kind of model diagnostics. So, that means first first hand requirement of econometry starts with linear regression modeling, and where we will discuss different aspects of linear regression modeling, and to address the engineering problems as per the particular requirement. In fact, the particular subject, this particular subject engineering econometrics is the extensive use of regression modeling. Of course, we have a different structure, we can change the particular dimensions, something like that as per the particular requirement, but ultimately the entire technical structure is on the basis of regression modeling. Then in the second unit under the classification, it will be nonlinear regression modeling, and that too we will discuss different aspects of nonlinear regression modeling, starting with understanding various functional forms, qualitative response regression modeling, models of discrete data, then binomial and multinomial probability models, discrete data and utility theory, then nested logit models. So, likewise we have a different kind of a modeling structure through which you can actually address some of the issues, and accordingly, so we have we have some kind of structures what we can call time series modeling, and then in the time series modeling we have something like components like trend analysis, stationarity issue, autoregressive models, moving average models, then ARIMA, all kinds of models are there to address some of the engineering problems, and we have volatility modeling, VAR modeling. Then we will move to the particular structure called as a penal data modeling, and in the penal data modeling we have the structure of fixed effect model, random effect model, dynamic penal data model, and generalized methods of moments. So, again we will have some kind of classification related to counting data, and then where we discuss some kind of Poisson regression modeling, then some kind of specialty truncated Poisson regression modeling, negative binomial regression modeling, zero inflated Poisson and negative binomial regression modeling, and then random fixed count modeling. So, these are all special category of modeling where we can address some of the engineering problems in a much better way and as per the particular engineering requirement or decision making requirement. Then ultimately we will move to the another kind of structure called as a duration modeling. In the duration modeling we have couple of different models. So, the first one is the random fixed count models, hazard versus duration model, non-parametric models, and then semi-parametric models, fully parametric models, time varying covariates, and then discrete time hazard models, and finally competing risk models. So, these are all special categories under this kind of econometrics basket, where we can address some of the engineering problems in a much effective or much better way. And likewise we have actually altogether different structure through which you can actually solve some of the problems as per the particular engineering requirement. So, let us start with the framework of econometric model, and so far as a framework is concerned, we start with something called as theory. So, that means in the definition itself we have theory, models and data, and in the models data we have some kind of techniques to get empirical kind of outputs. So, we have a input kind of cluster and output kind of cluster. Then we like to see how these inputs can be connected to get some kind of outputs. That is what called as econometric output and econometric input. So, that means technically it is the game between input and output, that to the econometric analysis for a engineering problems, and by default the first hand requirement is the observations, what we need to do actually. So, that is the statement of theory, and then that can be converted into some kind of objectives and the kind of hypothesis, and then we have models and data, that is in step 2. And once you have models and data and that too connecting to some theory, then we will go for empirical process, that is called as estimation process, and where we have to estimate the identify models or the derived models. And once you go for the estimations, that is in the step 3. So, you will get some kind of output, that is called as empirical output, and on the basis of empirical output we will go further by doing some kind of prediction and forecasting to a particular decision variables, and after that we can use these results for decision making process or the kind of policy requirements. So, the policy requirement of a particular organization or a particular corporate sectors. So, ultimately this is a kind of decision making process where we have some kind of tools, so which helps to make the things in a much better way, to get some kind of insights, new insights or something like that, and to address the engineering problems more effective way. And so, ultimately it is a kind of step by step process, starting with a kind of hint or the kind of theory or the kind of observations, then you connect with different levels of inputs and the kind of requirements to get some kind of outputs, that is called as empirical output or econometric output, to get insights, and that too corresponding to a particular engineering theory, and to come with a kind of decision where the engineering problem can be solved more effectively, or the engineering problem can be addressed more effectively. With this we will stop here. In the next lectures we will start with the typical structure of the econometrics and the kind of stepwise process. With this, thank you very much. Have a nice time.